Kubernetes isn't going to magically fix a bad architecture. It's not going to allow you to handle more transactions. It's not going to give you any more throughput on any other type of metric that you've conceived. And in fact, on the same amount of hardware, I would say that it's probably going to allow you to do less throughput, right? Now, when you do get scaling, a lot of times you get multiple versions of an application that it does help with. But let's talk about microservice. What is a microservice? Because this generally comes down to people say that microservices allow you to scale. And I would, again, say that these people are absolutely wrong. Microservices only allow you to scale your teams. Let's look at a graph that I made. In this example here, we see a classic microservice architecture. We have our different services, and these services have some access to some backend, your stateful applications down here. And each one of these allows you to have multiple of them. You know, we'll delete the. Allows you to have multiple of them because they're stateless and they're states in the backend. This is cool. All right, so you can do this. But the reason you have microservices is because maybe you want to have a team that just works on ads. Maybe you want a team that just does predicting the future of weather. It's for management of teams. Management of teams. When your teams get really big, it's hard to manage a really big team. You got to break them up. My general rule of thumb is you can't manage more than 10 people. If you have more than 10 people reporting to you, you got too many people reporting to you. All right. So this is something really, 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 really large companies do to break up their teams and manage their teams and let them work independently. That's what this is doing, okay? Now, some of you are going to say, but yes, Eric, but it allows us to scale our image service independently. It does. It does. You can make another, I just deleted it. You can make another image service independently of anything else. This buys you very little. This buys you very little. If these are small enough and are small enough pieces of code, having all of these packaged in one application isn't really buying you anything as far as scaling individual services, because you could just have another entire copy of this as a single application running on another service. The amount of code in here is megabytes at best. Think about it. Now, you're probably thinking of some edge case, and there is always edge cases to everything. So I'm not talking about edge cases where you have, you know what? A good one would be streaming. Right now, there's something that's transcoding this, that's doing something really heavy that you want to offload from your API server. Sure, that's a fantastic thing to offload to something else that's doing it, where your API server wants to just sit there and respond to API requests. Easy peasy. There's always edge cases. We're not talking about edge cases. We're talking about general. This is, again, you can have some ingress. You can have your stateless application and your stateless stuff down here. This can be its own application right here. Instead of it can just be pieces, parts of the router that handle different things. This really doesn't change a whole lot, and is what actually our Twitch events system is. There's actually 4 or 5 different pieces of it, but they're all in one application. Because, okay? So, this is a non-Kubernetes architecture, all right? And this is a Kubernetes architecture. So, what I want to point here is the types of requests that can't scale vertically or horizontally. And this is where, like, you want to add a X request number to the header. So if every request we want to integrate make this go one more. Oh my gosh, why can't I think of the stupid word? increment. We want to increment this. We want to add this X request number header and increment it on every single one. This is state that is in your server and doesn't scale with adding extra replicas, okay? On a Kubernetes architecture, it still doesn't scale. We put the same application in Kubernetes. We can't put another one in. It's the exact same. I'm just trying to make an example where people will see that this was an architecture design. We have an application that fills the X request number, and we want to increment it, which means that this is a single-threaded thing. It can handle one request at a time, and how fast this CPU core that it's running on is about how fast this whole thing can go. Our architecture doesn't scale. Putting it in Kubernetes didn't do anything with it. Now, let's talk about how we could make an architecture that does scale by adding new replicas to it. So in our stateful, we have two options. We can scale up. We can make our app instance bigger. And this is stateful, but this is not stateful. I didn't mean stateful. This is actually stateful. So this is a stateful app, and why stateless apps are important for this. You can scale up for free. It's easy. You just make the instance bigger. But you can't scale out. And the reason you can't scale out is replication and consistency and all those things have to be handled by you. So if you want to handle those things, you have to handle them internally inside of your application. So scaling here requires you to a second node with a stateful app, which, again, if we're talking about here, this was a stateful application. If we're going to do this, we've got to handle the replication logic to keep our nodes in sync, and we've got to do all of that. Maybe that's what you have to do, but that's a hard problem. And a lot of us can avoid that. We can avoid it by doing a stateless app. Databases do all of this hard replication natively in the database client or in the database service. They do the replication and all of that scaling for you in a single location. What this allows you to do is you can either scale these up or you can add more of them. You can make them bigger or you can make them make more of them. If we wanted to add another one, it's fine. No state is here. This is not a stateful. This has no state on it, and it will make requests to this. If you want to scale your database, you'll scale your database however your database scales. A lot of databases nowadays have methods for automatically partitioning and scaling them. That's what you'll have to do. So this is a method for scaling, but if you notice, this is a stateful app and a stateless app. Guess what I didn't say here? Microservice, Kubernetes, neither of these. Look at this, a stateful app on Kubernetes cannot scale any better than the stateless app out running on bare metal. Cannot happen, or does not happen. So basically just a general, what is stateless, stateful? A stateless app is just one where you store the state some other place. Most backends try to be stateless. It makes the problems easier. Now, why is a microservice application on Kubernetes slower or possibly slower than the application running on its monolith? Yeah. Check this out. Every single one of these is a call. We all love the moderation services because we all get moderated awfully a lot around here. All of these probably hit the moderation service. All of these are probably a network call. Yeah. That means in your microservice architecture, you have a lot of wasted network. You want to know what you also have wasted of? Duplicated code. A lot of times you have these apps running a bunch of different places, which means this app has to be downloaded on another machine. A lot more different machines. So you actually have extra memory tied up. So you'll actually have less room for memory because your application is loaded more places. And that overhead of having the application loaded is just this right here. But that's that in every single one of these. Now, I'm not saying there's not a time or place for some of these things, especially if you're at a company that has grown large enough to have the requirements of managing teams and people. But it's actually a price that you pay, not a scaling benefit. This is why Kubernetes does not scale. Your application has to scale. Going into Kubernetes because you're having scaling problems isn't the solution. Now, if your point is that you're having problems scaling your teams because you now have 150 engineers and 200, 300 engineers, and you're having a hard time scaling your engineering groups, you're having a hard time having them collaborate together and push towards a unified thing, now we can have a conversation about how Kubernetes can help. MySQL is not an option. Who put MySQL? That is a temporary ban. That is I know you're a first-time chatter. You should have known better. Should have known better. Easy temporary ban. I'm just joking. I'm just joking. I'm just joking. I'm not banning you. If you hadn't been first-time chatter, that might have been a ban, a short ban. You know, just a couple of months. But we'll give you a grace on this one. Thank you, YouTube and Twitch. That's my Kubernetes does not scale. I feel compelled to make it because I've been asked many of times, or I've heard people make statements around the scale of Kubernetes. And I just feel strongly, I like Kubernetes. I think it solves specific problems, but I think us as engineers need to look for what those problems are, and scale is not one of them. Scale is not one of them. Design your app to scale. And use Kubernetes to do what Kubernetes does. Kubernetes schedules processes, orchestrates processes. If that's what you need help with, Kubernetes is your thing. Let's talk about it. Let's talk about it. So now that we've talked about that, let's go on a little bit of a tangent of what are some things Kubernetes does, or at least in my opinion, does help with. So one thing that I think is interesting, there's a couple things. Now, for the most part, people run on a single cloud. So AWS, let's actually do this. We'll do like a data center bare metal. And then we'll do, nobody's using GCP anymore, so we'll do Azure. Okay. So one place that I think is, and this is for the unfortunate, but there are some people that are required to run multi-cloud, to run your application on all of these. So banks would be a good one. Banks have the requirement that they have to, by regulation, be in multiple sovereign domains. So they're usually in their data center with backup somewhere else or something like that. Some banks actually have hot standbys that are running in a separate cloud, okay? This can be regulation. This can be purely a requirement for that your business has, that they want to run multi-cloud because they think that it's a stupid thing. Don't do it. Push back on it. But this can be one thing because Kubernetes can do this. It's a unified execution layer. Sort of. It's a leaky abstraction. What I mean by that is there's stuff that leaks through this, like Azure storage classes versus bare metal versus AWS. Let's talk about load balancers on bare metal versus the clouds. This is a pretty leaky abstraction, but it does give you an abstraction that's going to help your teams write for one things, this Kubernetes, and mostly ignore what they're writing on top of. Mostly. You're definitely going to have sysadmins that are gluing this all together. You're definitely going to have leaky abstractions that are on top of this, but it's a better leaky abstraction than any other that I've seen so far. Maybe Nomad. maybe Nomad. So this is one place where Kubernetes helps. Let's do another. You have 500 engineers. And the best way that you've done it is you've broken out into independently deployable chunks of code. This is commonly called microservices, but you have these teams here. Kubernetes helps here. It's managing lots of small deployments, giving teams a way to deploy in similar or same ways, using the similar or same tools into the similar or same environment that allows them to network together without necessarily knowing who their buddy is. And it can help with this. But you need a big team. You need a big team. You have to be having this problem, and you have to say that this is the way to solve it. Again, this is all about the number of people, not about your code base. This is a way Kubernetes helps you manage large teams. Okay. So these are two places I see that it works really well. I actually think this is maybe an unsung hero of Kubernetes, allowing you to work on multiple clouds. Now, one that people will often state, but I'm hesitant on, I'm not sure if I agree or disagree, is infrastructure. I actually think Kubernetes is a lousy infrastructure. So a lot of people, some creators out there will be like, oh, I'm not an infrastructure person, so I don't need to know Kubernetes because I want a platform that manages the infrastructure for me. And I don't know that this is actually correct in any real way. You can do some stuff with horizontal pod auto scaling groups and things like that. And like there's some like domain specific scaling stuff in GCP and stuff. But I'm not convinced that this is actually good. A good statement. I generally think it's crappy at what it does or at doing this. And usually you use a lot of outside tools to do it. Right, but there's a team that is managing the Kubernetes, right? And they're managing the infrastructure. So that's just saying that somebody else will do it, not that Kubernetes solved the problem for you. I don't think this solves the problem for the infrastructure people. It doesn't reduce your need for infrastructure as code. You still have to write that stuff. So I don't put that. These are really the two big reasons I use Kubernetes or think are good. The last one is going to be a little contentious. I have one last one that I think is good. Is maybe a little more spicy. People are going to disagree with me. Is basically this, but for smaller teams of about 100 engineers. And it's not about managing the teams. It's all... Yeah, no, I think it's just this. I lied. It's just this, but for smaller teams. So one thing that for like 100 teams of about 100 engineers, let's say you have three things. And you want to... I have specific examples, but I can't talk about those. I'm going to think of a specific example, or I'm going to make a specific example. It's not necessarily microservices. It's just you have three services written by three teams. This specific example, I can't do it. It's just these two. Big team management and this. That's all I can do. Because the other specific example is like hyper specific, and I can't come up with a different example that's not like the exact same example. So until I can do that, you're just stuck with these two. It's this. I think that's where Kubernetes shines. If these are your problems, you're managing large teams or needing a unified execution layer across multiple clouds, that's where it shines. No. I mean, your engineering org has like 500 engineers. And to break it down, you're breaking into smaller teams. That's the point. Not that your team... I have said you can only manage about 10 people. So if we did this, we would have about 50 teams of engineers. Maybe 25 if you go with the upper limit, 20. So 25 teams if you have 500 engineers. I don't know about you guys, though. I struggle managing 20 people. That would be hard. I honestly, and again, I don't know if I've read it somewhere else, so I'm not trying to take somebody else's credit. I feel like just from empirical evidence, 10 people is probably about where I max out. Now, I'm not a people manager, so possibly there's some people that are really good at people management that can do like 20, like double what I can do. But then like, yeah, they're doing a fantastic job. I can't do that. I can't do it. Yeah. I'm with Dane. That's what I feel like is a, yeah. I'm not saying that there aren't people that can do 20 because, I'm thinking of a person. She probably knows who she is. She could probably do 20. But she's a really good manager. Yeah, Dane, agreed. Actually doing one-on-ones, if you have 20 people and you do a half an hour one-on-one, you have to do it bi-weekly. I like to do one-on-ones weekly, but you can't have a weekly half an hour and do anything else if you have 20 people. That's 10 hours of just one-on-ones, and you can't skip the one-on-ones. Can't do it. Ugh. Yeah. And then, goals and whatnot and mentoring and all of those things that go into it. You just can't do it. You cannot do it. And then like part of being technical leadership then is that you're also guiding the project, but you can't know what's going on in the project if you're spending 10 hours on one-on-ones and all the other time. It's impossible. It's just impossible. Can't do it. I can't. I can't sit in that many meetings. Can't do it.